Hiya! So today we'll continue tackling the question that we started last week. So we went through the entire derivation to prove the following result for in and in minus 1, where in is this integral up here. We want to use this result to then prove parts 2 and 3. So let's start with part 2. We want to show that if n is a positive integer, then in is equal to this expression. Let's go back and look at our toolbox. What tools can we use to prove this result? You can prove this directly. You can use contradiction. Or you can use induction. Proving it directly would not work. It is insanity because you need to make the factorial appear somehow. Contradiction is not going to work for obvious reasons. So the only option we have is induction. If we are to use induction, then we need to start with a base case. On the left-hand side, we have I1. Note that we are asked to prove this result with positive integers. So we start with 1. I1 is integral of x times 1 minus x. On the right-hand side, we would get 1 factorial squared divided by 2 times 1 plus 1 factorial. So 1 divided by 3 factorial, or 1 by 6. The two answers are the same, therefore, base case is true. Since this is a proof, please show all your work. You don't have to show this step, but you do have to show this before getting to 1 by 6. Otherwise, it can be seen as fudging your answer, and you will lose the mark on the base case. Induction hypothesis. Assume that it is true for n equals to k. In other words, ik is equal to k factorial squared to k plus 1 factorial. And we consider the case n equals to k plus 1. From part 1, we can replace n with k plus 1 to obtain the relationship between ik plus 1 and ik. And we're doing this so that we can use the result that we just assumed. Okay, beautiful. Where do we go next? Where are we going? What are we trying to do? Where do we want to get to? We want to get to k plus 1 factorial squared divided by 2k plus 3 factorial. This means that we need to multiply another factor of k plus 1 in the numerator. And it just conveniently works out. So upstairs, we have k plus 1 times k factorial, k plus 1 times k factorials. Downstairs, we have 2k plus 3 2k plus 2, and 2k plus 1 factorial. Upstairs is quite obvious. Downstairs is also very obvious. And this is the right hand side at n equals to k plus 1. And then you can just write your usual conclusion. So that's the end of part 2. For part 3, we are now lifting the condition that n is a positive integer. You're asked to find the value of I of a half and I of 3/2. So let's first write down what I of a half looks like. You are asked to use the substitution x equals to sine squared to show the results. So let's make a substitution. From this point onwards, the question looks a lot more familiar. When we change variables, we also have to change the bounds. X goes from 0 to 1. That means that sine squared of theta is equal to 0, or theta is 0. Sine squared is equal to 1, sine is equal to 1, theta is pi by 2. And this is because we only consider positive theta in these cases. The integral now becomes from 0 to pi by 2. Integral of sine squared of theta, 1 minus sine squared of theta, 2 sine theta cos theta. On this interval, in the first quadrant, sine theta is positive, cos theta is also positive. I don't really like what I'm seeing right now. It is looking too convoluted. So I am going to multiply the entire integrand by 2 and then divide by 2. And I am doing this because this will simplify it to sine 2 theta squared. This now becomes a very basic integral. Use your double angle formula to find this integral. Integrate. Sine of 2 pi is 0. Lower bound. And that will give you pi by 8 as requested. Now let's go back and do the last part of the question. Evaluate I of 3/2. So, seems like we should be making use of this result over here. The question is, can we? Go back to the entire derivation we have done so far. In part 1, the only condition that we need is n greater or equal to 1. and that's it. And does not have to be an integer, and just have to be a positive number. A half is a positive number. Therefore, we can use the result from part A to find this guy. Therefore, I of 3 halves is going to be 3 by 2 divided by 2 times 3 plus 1, I of a half. So 3 by 16 times pi by 8, and that will give you 3 pi by 144. No, 128. And this is the end of this epic. I hope that the discussion on choosing the right proof techniques was useful.